now my screen?
Yes.
Yeah, we can see.
Okay, okay.
Yeah, so I think let me welcome the speaker for today. I welcome Chanchal Das for the Zoom for the Math Clinic talk today. He is basically a mechanical engineer with postgraduate diploma in operation research and an MBA in financial management. He started his career at Hindustan Fertilizer Corporation and then later joined ONGC in 1990 as Assistant Director Reservoir. He is the recipient of the World Oil Award as Innovative Thinker and Asocam Ericsson ICT Startup Award. He has published and presented numerous papers and attended various national and international conferences. He is the chairman of DAS Scientific Research Labs Private Limited and DAS Oilfield Technologies Private Limited. He has been an advisor to the Government Technological University for approaches to teaching engineering mathematics. He is the fellow of Institution of Engineers and member of many other societies. So without taking more of his time, I will request Mr. Chanchal Das to start his presentation on geometrical interpretations of mathematical concepts. Please, Mr. Das.
Yeah, thank you, sir, for nice introduction, and I'm very happy to that you have given me this opportunity to share my ideas on mathematics and what I am trying to do, and definitely I'll try.
I will request that please limit to 1 hour because then we would like to have question answer sessions after that. Okay, then we can have a second session in case required later on. But please limit to 1 hour because we have announced 1 hour talk. Please. I'm sorry for some technical problems. He is trying to log in again. The speaker is trying to log in again. So please bear for some 2-3 minutes so that he logs in and then we are back.
Am I audible now?
Yes.
Okay. Thank you. And my screen is visible?
Yes, screen is visible, everything. Please go ahead.
Okay, okay. Thank you. And sorry for this disturbance. And let me continue. Today, I will be presenting on geometrical interpretation of mathematical concepts. And this is the pain point on which I am working. That pain point is the difficulty in understanding advanced and abstract mathematical concept. It is a global problem, and every student, I think, face this problem. And we have a solution that mathematical modeling and animation with DassMath can help in making abstract mathematical concept accessible geometrically. And here we use technology, Microsoft Excel only, and no coding and programming knowledge is required for this. So with this, I am trying to explain how we are doing this. So this is something written about me, and I think Sir has told that, and I am not spending time here. And this is the thing. Actually, my objective is to explain a new approach of teaching mathematical concept. And most of the talk will focus on this point. So actually what I am trying to do, symbolically, if I tell that what I am trying to do here, if we ask what is mathematics, so this will appear in our mind that there may be many symbols, formulas, equations, a lot of things, and it appears to be infinite thing, and it is endless. But if we think that mathematics from points, lines, surfaces, then it will be having some few limited items which can be accessible. So I am trying to that mathematics is not that only symbols, equation and formulas. It is some points, lines and surfaces. And if we see this mathematics geometrically, every mathematics become very easy to understand. So this is the my thing, and with that we have established this DassMath lab, and here we are doing research on mathematics. And our objective, what does that DassMath lab want to do? Actually, we want to be world leader in simplification of advanced mathematical concepts. Means any concept of mathematics, anybody who is facing a problem in understanding from any corner of this world, we should be able to help them. So our activity is this simplification of advanced mathematical concept, development of effective math teaching technique, publication of books, recognizing the mathematicians engaged in mathematics education, promoting and popularizing mathematics, organizing mathematical workshops, and initiating Ganit Pe Charcha campaign. This is a, I think now time has come when we start talking on mathematics. We in general avoid discussing anything on mathematics. So what I am trying to do in DassMath is this. You can see that teaching mathematical concept in applied way. I am not in favor of applied mathematics. There is no mathematics called applied or pure or abstract. Mathematics is mathematics, and we can use it in applied way, or pure thinking means what I can do in a geometrical way. So many people can do it intuitively in their mind map. They can visualize those mathematical things. So whoever comfortable is in which method, he can do that. But this is mathematics is same. Mathematics is for all. It can be applied, it can be abstract, it can be something, but there is no distinction in mathematics. And what is this applied way? Applied way means if I think of this mathematics, no, any mathematics having three basic class, I think group. If you learn these three things, you can do any mathematics. And what is that? That plotting graph in MS Excel means somebody, if you have to model it, if you have to draw something, you should be able to draw it in Excel. And then matrix multiplication, that is also one keyword available in Excel which you can use. And this matrix multiplication, this is whatever operation we want to do, from simple addition, subtraction, division, multiplication to exponentiation, to that transformations, all the transformation, everything, even calculus you can do in Excel without going in details, without any programming knowledge. And last thing is also creating animation. So we can see we are dealing with a dynamic world. Actually, engineer, scientists, technocrats, they are responsible for capturing the dynamic world phenomena. And this dynamism can be captured through animation. So this can also be done in Excel very easily. So what we are teaching through DassMath is that you learn these three tricks. This is very simple tricks, no programming, no coding is required. And these three things, when you learn, you can solve, apply it in any mathematical concept, any physics, mathematics, chemistry, mathematics, engineering, mathematics, medical mathematics, anywhere you can apply. These three things are common. So in applied way, if you try to learn, then you learn these three things and you can learn all the concept. Now, today I will show this how we can do. I have taken 5 examples from 5 fields: mathematics, modeling differential calculus, how we can do that in Excel, then modeling projectile, this is from physics, then engineering, modeling Watt's mechanism, and environmental science, modeling Lorentz attractor. And this, you can see this Lorentz attractor, it is a differential equation of 3 differential equation involved in this, and you have to integrate that to solve those equations. And this is a 3 dimensional problem. So everything you can do in Excel very easily. And then lastly, I will be doing a fractal geometry, which is the geometry of nature. So my first question, why we require a new teaching technique? First thing is that at present, whatever we try to teach mathematics, no, we stress on problem solving. We give the student that you learn a formula and try to solve this, and we try to test that student whether he has learned that formula or not. But we are never give stress on concept understanding. So our education system is at present is that we are not stressing concept understanding, we are stressing on rather problem solving. So for me, I think we should change this trend, and the reasoning of this change is I'll explain that also. Then why we want to require to change that? What I feel, when I was in my school or in 1970s, that time there was no technology, no technology. We are not knowing about anything about any technology. Simple sending a message used to take 10 to 15 days to reach a postcard. And now we are living in advanced technological age where everything is technology available. So there are tools available to calculate for you. We need not calculate anything. Everything can be calculated, and tools are there. So we can now concentrate more on concept so that we can learn the concept and we can create new concept at our end. And for some examples, I am giving the tools available. My very favorite tools available, MS Mathematics. It is Microsoft Mathematics, and it is available free, and anybody can download and work. I don't know why it is not that much popular, but it is a very good package. No programming knowledge, nothing is required. And then Matlab, Mathematica, Scilab, GeoGebra. These are all the tools are there, and most over this Google calculator. Google calculator, there you need not learn. There you need not learn anything. You just whatever you want, you just Google it and you will get the answer for that problem. So technology is there, and now so I tell that now we should know what to be calculated, how to be calculated, not that we should calculate at our own. So this trend has changed. This I am trying to show that now you have so many technologies available with you, and you can use those technology for solving that thing. But you should know that what is to be done, how to is to be done. You have to instruct your as this technology. What I mean to say, your laptop, your computer, your mobile, they are your servants. They can follow whatever you tell to do, they can do it. But you should know that what to tell them. So how to solve the problem. So that part. Though, so concept you know, then you can take benefit out of it. So I am showing some Microsoft Mathematics. It is a simple interface, and you see it is having worksheet. Here you can give the calculations, and then very good graphic package. And it has I have shown the earlier I have shown the total package. Then I am left side portion I have zoomed, and I am showing this, and these are the thing. You can see complex analysis, calculus, statistics, trigonometry, linear algebra, standard calculations, favorite buttons. All this you can do very easily in Microsoft Mathematics. And you see that I suppose I want to calculate d cos x by dx. So I will give this formula in this worksheet, and then this is the output. This is the computer will calculate for me d dx cos x is equal sin x is equal to cos x. So this result will come automatically. And here also, would you like to differentiate on x? or integrate on X. So many options are there. Even problem solving, they can show step by step how the problems can be solved. Similarly, it has many other good features. You can see that here you can use real numbers or complex number for solving problems. Then you can use this. You can use this radians, degree gradient in anything you can use here. And right hand side there is a equation solver, then formula equation, triangle solver. All these things are there. You can take advantage of it. Very simple. And this graphing, you can see this graphing also, it is having a very nice graphing capabilities. And means you can get more than what you expect. Here you can see that 3D, 2D, all graphics you can do, and spherical, Cartesian, cylindrical, all the system you can do here in Microsoft Mathematics. And now coming to the differentiation and integration in Matlab. In Matlab, there are ready-made packages where you can directly calculate this differentiation and do this integration. And there are one symbolic math toolbox where you can give the formula. This is y is equal to, suppose this is x cube plus x square plus x plus 1. And then give dy dx is equal to d yx. So it means that I want to differentiate y with respect to x, and the result will come like this. So you can see that here the power was 3, coefficient was 1, and now coefficient has become 3 and power has become 2. And like that, its coefficient, x square coefficient was 1. It has become 2, and x power has reduced here to 1, and there is no x, constant term is 1. So like that, into y x means this. I am asking Matlab to calculate integration of y with respect to x, and the result is here. And here also you can see directly that their power of x cube has increased. It is, and it has been divided by adding 4. So 3 plus 1 by 4, then 2 plus 1 by 3, like that. This power has increased by 1, and the coefficient become 1 by 3, and for all the terms. And you can see there is a trend. Now, from this also we can correlate one thing. You see this, it is a polynomial, can be expressed as a vector. 1, 1, 1 is means it is the coefficient of this polynomial, and this computer will understand that when you give this, it is 1, 1, 1, 1 means it can be a polynomial. And you have this formula for deep yx, and here also from that coefficient you can extract there here in from integration and differentiation, as we have done last time. And then there is a this is actually symbolic toolbox. So it is not main package of Matlab. Matlab package, when we go for Matlab, then this is the polynomial derivative. So if you write p is equal to 1, 1, 1, and then dp is equal to polydor p, it will take that p is a polynomial, and the coefficient is 1, 1, 1, and the result will be 3, 2, 1. That means this is also a polynomial of coefficient 3, 2, 1, and when it is 3 terms, then it degree is 2, then it's 3x square plus 2x plus 1. And similarly, polyint means this is the polynomial integration. So these are the things. So Matlab also there. So readily you can calculate. So students are struggle in calculating mathematics things, and easily they can calculate this directly from the technology available. Even you can Google it. Integration of this equation, if you write, you can get the result. But now I'm talking about this Excel, power of Excel. Polynomial differentiation and integration can be done by matrix method or Excel, and it is answer is yes. You see, this is the this 111 I have seen written in blue color. This is our polynomial, and polynomial power I have written from top up. So x cube, x square, x1, x0, and the blue yellow coefficient, yellow matrix, which is having 4 by 4 matrix. It is having a pattern you can see, and this is the representing the matrix for differentiation. And this yellow and blue, this is the, if you can multiply, you will get this the result for this cubic equation. So whatever the polynomial you have, if it is degree 3, then there will be 4 by 4 matrix which you can calculate, and you can write the coefficient here and you can get the result. And as you seen that there is one term vanishes, so x cube term will not there. I have written it in red. So very nicely you can do all polynomial different derivatives you can calculate easily in Excel. And similarly, you can do integration, and you have seen that when we integrate, then one term increases. So we our polynomial was 1111 as a form term, but it will have a extra term. So I have added x to the 4 also. And when we multiply, this is the green matrix is the integration matrix. So when this green matrix and this polynomial, this is, you see, 5 by 4 and 4 by 1. So result will be 5 by 1 matrix, and this will be the coefficient of the polynomial, and x cube, x3, like that. This will be the terms. So like that. So what I may try to convey that technology is there for solving for you. Earlier we had to we are required to solve all this manually, but now technology is there. We can use that technology. So what I can say that this is the summarized I have done here. Here I have written that 111 was the polynomial. When differentiate, we get the polynomial coefficient 1, 2, 3, and when we integrate, then polynomial will go on increasing. So I have taken this right hand side here to ready reference, and top heading is given this power of x of each term. Now, what is that? I have shown that calculation is now available, and there are somebody who can calculate for you. But we should now know that what is the calculus. So when we come to college, and then we get that big book of calculus of Thomas Finney, then the Stewart's and all those things, 1200, 1300 page books. And from before I started my research, I used to wonder what is written on this big book. So many things, endless, and we can write, we can extend any of the chapter. But can we summarize what is that calculus there? So in that I have seen that calculus is the story of 2 lines. In this whole book, we have written the story of 2 lines, nothing else. And we have seen that from different perspective, different angle, and we have extended. But ultimately, it tells about the story of 2 lines. Story of 2 lines. Definitely, if any student understands calculus in this way, that is calculus is nothing but a story of 2 lines, then whole phobia will go from him. So this is the thing, story of two lines. What is the two lines? First line which represent the function, that is the I have taken a function of x cube power 3, and it looks like s, and it's tangent in one point. So this is the story of two lines, and whole the subject of calculus are based on these two lines. Now I am trying to understand that what are the topics involved in calculus. If you see any calculus book, you will see that the calculus book starts with number system, then set, then relation, function, continuity, limit, derivative, differentiability, and differentiation, integration, series, and application, or application of all those things. Now questions come. I have grouped this in three colors, and you can see that these colors, we can understand the relation and function. These two, yes, there will be two set of things, and we want to establish relation from there, and that relation we is the function, that all these things. But why we require to learn number system again when we start calculus? That one big question remains. And then function and relation, after that it comes to limit, continuity, and differentiability. So why we require this? Why I have experimented it with many number of students and faculties, and everybody have I could not find anyone who has given the practical problem of introducing limits. They explain something, something as it is written in the books, but the real problem which is required to solve and the limit was introduced, that story is not available to many of us. So when we see this in mathematical modeling way, you can understand this very easily. So these are the questions: why we study limits, why we study continuity, the story and continuity. Is it means essential for learning calculus? All those things are there, so we can concentrate more on those than the solving calculus problem. And these are the things why it is not differentiable, and this is what is this is a function, but it is not continuous. So something is there, and when we see this all are geometrically, it easily we can understand that what is those things in theory. And when we come to this differentiation, suppose y is equal to x square, this is the thing, and what I think.
Mr. Das.
Yes.
Can you, people are putting questions, how do you are doing in Excel? So we want to know that. Can you example
yes,
of Excel?
yes, I'll try to cover it. That's why I told you that you be patient, and I may take a little bit more time, but I'll show
please,
that.
please. I think we are very clear that we have 1 hour and we want to
yes.
understand.
Or we can put a this is the introduction level, so that people will know that what can be done in Excel and what cannot be done, and then we can have a practical.
Yeah, but I appreciate that people know calculus. So how do you?
No, it is not. Knowing is not sufficient. That I am telling. Actually, when we are trying, you try to understand what I am trying to convey. It is I am telling not from my teaching you that you don't know calculus, you learn. I am teaching it because we are required to learn to the teach the student in a way where what he will understand. Here you see that when we teach that y is equal to x square, we create this x square graph, and then we try to calculate its derivative, and matter ends there. We never correlate it with practical use. Practical use means what I am saying, x Actual problem is that when x, the side of this square is x, then when x increases, then what is the area increases. And these things means why we require limit can be modeled here and explained very nicely. Otherwise, theoretically, I have also learned that my teacher told me that I never can conceptualize or intuitively think what was he was trying to convey. But now when I do this in modeling, I know that why I am required to do that and limit why we require from these points. And all these are animated, not I am showing here in a static model, but I have Excel animation. Here now I am coming to this physics problem. Earlier I had in my school days in higher secondary, I was taught in physics that when we throw at 45 degrees, the object travels a maximum distance. But that time I never, I never used to think that it is true, because I used to think that I am throwing, if I throw it horizontally and with same force, then it will if I throw it in angle, then it will go up and then it has to come down. So it must travel less. And when we throw it horizontally, then it should go maximum distance. That was my thinking. But as I have learned the formula, I could solve the problem. We applying the formula, I passed and everything was nice. But I never believed that it can happen like that. But once I start learning this modeling, when I modeled it, and then I realized the gravity plays a role. But in daily life, a student never can realize the gravity of a gravitational force, and he never can realize that why it is at 45 it goes maximum distance, because we never think. Now I have a model and I can play with the gravity. I have tried to nullified the gravity effect by reducing g is equal to 9.81 to 887, and I have seen the effect of that. And if it is not gravity, then the general idea of what I was thinking, it should, when I throw it horizontally, it should go maximum distance. That is true. That is true when there is no gravity. So all these things, physics, chemistry, mathematics, can be explained very easily. And once they can they learn this technique how to do it, then it will become very simple for them to do modeling in any field. Now this is the thing I trying to explain. Now this is another model I have created in kinematics, which is that, and this is the actually Watt's mechanism, and the straight line was explained from this. And James Watt, he claims that steam engine was not his greatest invention. His greatest invention that this middle of this crank rod middle arm that traces a straight line. And how this trace travels in a straight line, that unless until any student can model it, never can. Few hundred times I tell it will travel in a straight line, but I know that it is all moving in circular or semicircular way. So, and elliptical way. So I never will let it can be a straight line. So when we model, then can only we can understand that. And all this model has been done, and animation also done it with this. So these are the things, and there is another problem when we see that this is a rocker thing. So sometimes it can circulate this follower arm, and sometimes it rocks. So when it rocks, when it will circulate, all this relationship can be modeled from a single model. You can go on trying all those things. And this is the most favorite one is of mine. This is Lorentz attractor. As I told initially, that it is a differential equation. 3 differential equations are involved in this. And when you solve, it is required for solving integration. and then integration. After that, you get x, y, z, and then if you plot, it will plot in 3D move. And there are so many strange properties are there. It is called a strange attractor, but a strange property is there because in this a small space, this no line process any time. Never it will intersect anyone, and never they trace same line. So all these things happens within this short span of time, and sometimes they move in vertical way, sometimes then it travels to horizontal, or then directly to goes to horizontal vertical, and then sometimes they move it in horizontal and then go to vertical, like that, all those things. And you can animate everything in this Excel, and no coding, no programming is required. The solution also, integration also done without any formula. And this is a farm. Farm is that fractal geometry. Now, fractal geometry has two properties. One property is that this is very high, means advanced level of mathematics, but geometrically, when you see, then it will become very simple. What it tells, when this is randomly, all the plants of human to any object in this earth as being created randomly, but still they have a particular shape. I cite one, two examples. That cloud. If I show a picture of cloud of everybody can understand this is a cloud. So cloud, nobody will question whether this cloud was clicked in US, UK, or India, or anywhere, because that has a definite shape. But cloud never forms with a formula. It generates randomly. So in randomness also there is a regularity. Fire, when I show anybody a picture of a fire, everybody identify it is a fire, but they never can question that this fire is from petrol or diesel or from paper burning or any other things. So they can identify it is a fire. So definitely the fire is a random phenomena. It is having a regular feature. So here also mathematically I have created this farm leaf. This leaf, all the points, they are randomly put. It is not that I have put knowingly this to form a farm leaf. So randomly I have calculation, I have made calculation with random data. Randomly I generated that points, and then when I put this all points, I got this farm. So in this randomness also a regular figures are there. So it is not really chaos. And when I talk about fractal geometry, then two things matters. One is infinite divisibility and self-similarity. So two things, any object in this world, any object, if you can divide in two or multiple pieces, then every piece should be same, similar by appearance, and infinitely you can do that. Means you can divide it 100 times, 10,000 times, million times, but every time you will get a similar object. So I have given an example, a cube. First, I divided it into two parts. So when we divide it cube into two parts, we get 8 pieces. And 8 pieces, you see that 8 pieces all are cubes. And then another cube I have divided into 3 parts. In that 3 parts, when I divided it, so we got 27 pieces and all are cubes. So this is the base of fractal geometry, and natures follow this fractal geometry that we don't mention. There was a mention in class 7 book, fractal geometry. Then up to 12, there is no repeat of that term. I have seen all the books in NCERT, and college also. Fractal geometry is still not there in our engineering college and many colleges. So this is the thing. After graduation also, people don't know what is the geometry of this nature. This is actually geometry of nature. And I have seen this creating this as a 2D, and this is also trees I have created in mathematical modeling Excel. And this is my thought level, and there are many things. I am working almost all the mathematical topics, including abstract algebra and other things. And so now question comes how I do it. My let me try my other laptop whether it is, because that Excel file is there. It is here also, but there I have made it for nice presentation. Let me check whether. So first I show this Excel, how we do calculus in Excel. Here you can see this is the simple function x square y is equal to x square, and this is the tangent line, and how I have calculated here, it is available here, and how I am animating it. At any point we can get the so now I'll be showing same graph. It is x cube graph and y dx dy. Here I have not used any formula for creating this. Everything was calculated here, and here also you can see this animation at different points. So when we see this graphically or geometrically, here you can see very much easily that the derivative dy dx can take three values. Three values means positive, negative, and 0. So when we it is 0, then it is a horizontal line, and that we use extensively in maxima minima. But when we try to understand maxima minima, at least college level, what I was taught, I was trying to remember this first derivative with 0 and second derivative plus or second derivative minus, and I was more concentrating on remembering those formulas. I never get to know that it is the horizontal derivative where it matters. So this is the advantage of geometrical interpretation. And then the graphs, this is the graphs I have created where I have shown that why it is not differentiable. This is cos pi by x equation. This is not continuous. Then there are, this is a model x cube one curve is there, and its radius of curvature. So radius of curvature you can animate it, and you can see that how radius of curvature differs and how it is changing. And this we used to struggle in school and colleges to get these formulas remembered. But once you can model it, you can this left side I have done it all, zoomed it, and here I am showing it is and where curvature is more, the circle is becoming smaller, and some point of time the circle changes, the radius of curvature changes from direction also. And these are the same thing. Actually, here when I told that dy dx that modeling matters, this was I was trying to convey. here you can see that there are two issues. One is x and one is delta x. One is x and one is delta x. So x, we want that when x increases, that means x will increase. And what will be the effect of that on area? That we want to know. So x will increase. And there is another thing, we use a term increment or delta x, which is we take a help for calculating that derivative. So what is the effect? When we take this increment high, then x square, when x increases, then x square value will be higher than the actual. And if the increment is very less, then the actual area will be same as the x square. Suppose x is was 1 and then x has become 1.5. So area will be, or suppose 1 and 1, so it is 1 and then it has increased to 2 by 2 means 4. So when x increases from 1 to 2, area increases 4. But what is the effect on delta x? So if we keep the delta x very high, then this 4 will become very high. And how can we show that? That I can now, as I have seen modeling this, this increment I can increase or decrease, and this effect also I can depict here. Then I can realize that what is the x is not increasing, x is same, but the delta x, it is not that what values we are, the rate what we are increasing the x, the increment value of that x. So if we take a larger increment value, we will get a wrong area. So that is the beauty of modeling here. In this I am showing that delta x as small as possible you can take, then the area of increase x, that will be, means area will be the more accurate. That is the thing. But when we tell these to a student, many student visualize this in different angle and differently. So they never can realize that what actually this means. When we model this in two different things, that this is the actual x is increasing. Now see, del x square is not, area is not that much increasing. But if I put this increment is higher, suppose initially I put this increment higher and then I increase this x. So this area also increase, means the resultant area we will get is not exactly same. Now it is Lorentz attractor. Lorentz attractor, as I told you, that it is having three equations, and that three equation, sorry. So this was my intention to show, and here you can see these things, how these are the calculations, and these are the things we have done in 3D in Lorentz attractor. Then projectile. Here projectile I have done. You can see that projectile at different angle, what will happen if you can go on changing, then you can, I have put it some particular fixed angle in this red and green. And one thing is I have put in, I think that
Mr. Das.
yes.
There are questions in the chat box. I think if you do that, that will be very good. because
I'll attend that chat.
yeah. So please, there is a question that take so a simple example in Excel that y equal to x square that you took. How did you draw the graph? How did you draw the tangent? And how did you move the tangent? So please take a blank Excel.
Okay, I'll do that.
Take a blank Excel sheet and do that so that everybody understands what is involved in doing it.
It is very simple thing actually. And
yeah, please do it.
I'll do. I am taking a new sheet, okay?
Yeah, on a blank Excel.
Yeah, blank Excel sheet I will take.
Yeah, so that will answer the questions raised by Rita and raised by other person, Muhammad.
Yes. Now you see, it
we
is
can't
very
see
simple.
We have stopped sharing, I think.
Okay. I'll again. Now, is it visible now?
Yeah, it's okay. Please go ahead.
Okay. So simple, and one worksheet you do, it can be used for hundreds of functions, whatever functions available in one variable. No, everything you can do from the single sheet. That is the beauty here. Suppose you have x and y. So you take x as a independent variable. You can take from suppose -3 to and increment it. We don't want it that much. -3 to 3 something we can do. So I am just removing this one. Let us do it for a sine curve. That will appear very nice. So this is the is equal to sin x. So and select these two and insert the scattered chart and this. So you see that nicely it has plotted this chart. Very simple way. And one point I want to mention is that if you do anything in Matlab, GeoGebra or any other modeling, you have to write different, learn different things for different purposes. But here you will be learning one thing, this just modeling, first modeling, then animation. And by and when you are doing that, you will be knowing the importance of all the things we learn from school, class 1 to engineering. Why many things, many people cannot realize that why we learn that. So here it is available here, our sine curve, and I want to tangent at any point. I'm not fixing any particular point. I'll arbitrarily take a point and then I will draw the tangent curve. So tangent is a straight line, and this straight line requires y is equal to mx plus c for calculating that, and y is equal to mx plus c when we require, then we require m and c. This is the first thing we require to understand, and we know all those things. And as we claim now, our students do not know mathematics, so I don't agree on that. They know this, how to do that. All the here in radians, when we do talk about calculation in computer, generally all the angles are taken automatically in radian. So X, suppose I want to draw a tangent at -2. I am taking arbitrarily. Okay. And what will be our formula? Formula, I will not copy this formula. I will copy from here. So whatever formula is, here formula is Control C, and here we will put a Control V. So -2 is 0.9097. So formula also I copied. I will not, yes, -29093. So this one point is available here, X and Y. So we want del X, del Y, then del Y, del X. So when I will do, many people will tell that this is the crude method of doing that. But I tell you, it is not crude method. This was the method. I should share this information also, that Leibniz and Newton both worked on calculus, and we can say that simultaneously they develop this calculus. And dy dx classically used by Newton, and England used that Newton process of calculating dy dx. And US started taking, followed Leibniz, and they started doing the technique what I am doing now. So as a result, after 200 years, it is being said that England was far ahead than any other during that 1700 period time, ahead in science and technology, that they started lagging from that period onwards, and US over to, due to one of the reason is this, because here they used to follow calculus by Newton and the Leibniz. Now we want dx. So what is the dx? I will take it also arbitrarily. Suppose this plus 0.1. Why I require this? Because from one point I cannot draw a line. I can draw hundreds of lines from one point, but I cannot draw a particular line which is called tangent line from one point. So Newton faced this problem, and he took a close point near to that point where he wanted to calculate the calculus, and took a very close point, and then he calculated. Formula is same for both. So here dx is equal to x2 minus x1, simple. dy is equal to y2 minus y1. Then dy dx is equal to, so I should, from this data up to this, I can very well see that it is dy dx is minus 3.7. I can guess that this is a decreasing line. One line is two types, decreasing and increasing. When we go from left to right, if it goes up, it value should be positive, and if it goes down, then it values should be negative. So here I can say that this derivative, it is line should be downward. And now we got x, y, and m. This is m, dy dx is m. Now I want C to draw a line. C, what is C? Then this is the C is y minus m into x. So formula is, we know everybody that y is equal to mx plus c. So we have m, x, y. So c is this. So this is the c. Then for a line, we got every information, m, c, and x, m and c. So we can draw any line. So One point already we have, we can take it or we may not take it. This is the point we have already. Now for drawing the line, what I will take arbitrarily a point, this point minus 1. On left side I will take one point, and sorry. And another point I take right side at 1 unit right. You can take any number. If you take 2, 3, then the line tangent line will be very big. So I am restricting it to 1. So I got this is independent variable. So I got minus 3, minus 2, minus 1, 3 points. And now I have to calculate that y. Y is equal to, this is actually M and C is common for all the points, is equal to, this is x into, this is the M plus C. So this is the tangent line values. Now what I will do, I will plot it. Select data. Same chart, I will add another chart, and then this is x values and this is y values. So as I told, it will be a downward line. You can see that minus 2 here, this is a downward line. Now you can do many things in that formatting and all those things you can do. You can add label. You can put, when you put label, it will give the y values. You can put the series name, name x, y, all these things you can do. And series name also you can so series we have not given any name, so series 2 is coming. So this is the thing, and you can also thickness and all these things you can do as you require. Style, then end line you can add some arrow to show that it is a tangent towards this, and you can remove the marker option none, so that you can. So this is your tangent line. Here also you can remove the marker lines. Now how to animate it? Second question is there. Now what I want to do, I want to change x, and automatically everything should calculate and plot. I need not do anything manually. For that, what we will do, I will go to some tool which is called developer and insert, and here I can choose this, and it is called a what is called slider. So I have added a slider, and then right click it. A slider, now if I click, nothing will happen because I have not asked him what to do. So now I am giving some instruction. There also no coding is required. That is the beauty. Coding is there, format control. And here it is 1 to 10. These values actually you can see minimum value 0, and there cannot be any negative value, and there cannot be more than 3000 something values, and all are integer, positive integers, and increment can be 1. So you cannot add negative and fractional values. And you have to link where you want this slider value to input. So I will link it, suppose this cell, now this cell. Okay. So if I now click it, you see this cell number is increasing here. So this number is increasing. You can, there is a lot of other options also to do this, but this is a very good option for animating. And what I want to do, my only input here is this point, this point. I am putting this in yellow cell. So here, this point I want to change, and I want to animate it at different points. So I want to go from negative to positive. So I will play some trick here. I will not put here -2 directly. I will take this value. Then suppose I want negative values as well as positive value, means decimal values. So what I am doing 10. So in this case, I am telling that this cell E3 cell, you get minus subtract 50, and then the result you divide by 10. So we get some values beyond 0, means negative values, and divided by 0 means it will be decimal values. So now you see that it is 4.7 here. So 4.7 values available. Now if we can so these are the things, and maxima, minima, I had Rolle's theorem, all the theorems, Hospital theorem, and whatever is there, everything I have animated in this. And calculus, I teach only 1 hour in my total session, because it is very easy subject when we go for geometry. And this is done also partial geometry, also integration also.
Mr. Das, do you have any link where some of the Excel files are available, or they can mail it to you?
Yes, there are a lot of hundreds, 500 Excel files, because I do a lot of things, and micro level I do.
No, I'm asking whether there is a link from where people can borrow some, or they should mail you to get an Excel link.
You see, my suggestion is that this does not require much time. So one session of 2 hours maximum, they can learn all these tricks themselves, and they can devise the thing. Because when they see these files, I'll show you some files.
Yeah. So the next question comes, to learn how to do these things. Is there any documentation available?
What I do, you see, I have written many books already. 4 books I have published, and I have presentation also available. And
yeah, so I agree. So can you tell the names of the books so that people can read those books? So it will be good to have material to refer and read, right?
In Kindle, Amazon, you can give Chanchal Das. So all my books you can get.
Okay.
Can I show you something from Amazon?
No, it's so you can go to amazon.in and
just wait.
The author by name Chanchal Das, and you will get the books by him, so you can do the needful.
Amazon, you see, I am in Amazon now. Can you see my screen?
Yeah, it's visible. No, I think everybody knows how to get from Amazon.
Just I'm showing what are the books available there.
Yeah, so in the meantime, anybody else would like to ask a question, please ask. You can either unmute your mic or ask the question.
Here you see teaching and learning mathematics, mathematical concept, Matlab, app designer, 2D modeling and animation. My quest for eigenvectors. This is my latest book in linear algebra.
Yeah. So links for learning are there. Anybody has more questions to ask? Yes. No.
Sir, can I ask one question?
Yes, please.
Sir, can we use by using GeoGebra?
Can you reduce your volume a bit? It is too high.
Okay, sir. I will make it.
No, GeoGebra, I have good experience. Actually, I have first I learned this mathematical concept when I felt that we can, if I learn geometrically, then we can learn mathematical concept easily. And with that in mind, in 1999, I joined one 3DX mathematics course, which is the software for this what is being used in cinema industry for animation, film, Maya and 3DX Max. So I learned that, and I learned all the mathematical modeling and animation what is being done in that 3DX Max, and I am a master on that also. But I tried to animate this projectile case. I'm sharing that experience for your clarification, because I am doing it wholeheartedly. I left my job and engaged fully on that. So
thank you very much,
to,
sir. Thank you. Thank
yeah?
you very much. I understand.
Okay.
Thank you,
So
sir.
I tried to do this projectile. Let me just 2 minutes, sir.
No, it's somebody else wanted to ask. It's okay. Go ahead.
So this projectile I wanted to animate in 3DX Max. I could do it, but I could not understand the mathematics because they are doing programmatically. So program is written for that, and we are just following. So I then shifted to Excel and not Excel, Matlab. I learned Matlab, and Matlab also everything whatever I want to do, I require some separate toolkit or toolbox or package or programming. So that was also not, I was not that happy. Then GeoGebra I tried, then Mathematica I tried, Scilab I tried, and almost all are similar type. GeoGebra a little bit good because a student can directly draw many things and add this transformation, means they translate, rotate, everything they can do very easily. But the mathematics, how this is rotating, that they will not learn from GeoGebra. They maybe they are, that I should not say that it is not there, maybe they are, but it is not there readily. But in Excel, when you do Excel, there is nothing. So you have to learn how to rotate it, how to model it, how to write, draw a straight line, how to draw a function. Every mathematical concept you will learn, and then you learn everything, and then you can, if you are master in any package, you can use that. So this is my experience. So your question was GeoGebra. It is a good thing, and you can try it. But learning concept, I feel Excel is best.
Yeah, I think there are many softwares, many visualization tools available for teaching and learning, and everybody has his or her own preference of.
Yes.
But that's why there are many.
Yes.
Right? If one could satisfy everybody, then others wouldn't have come up. So I understand that you like Excel because of some reasons. Maybe likes GeoGebra for some other reason. So, but it's good to have more, because I feel Excel is more from the point of view of data collection and data interpretation, right? That is the way it goes, and you have to know mathematics to interpret it. But on the other hand, GeoGebra does not do that. It just gives you the visualization, much bothering about the data collection and such things. So I think both have plus points, both have your own preferences. So if anybody else has a question to ask?
No, another advantage I should share. Sorry. Another advantage I should share, this animation part. Animation part is very nicely you can do in Excel. Even I tried Matlab also, and Matlab also slider is there. But adding a slider, it will be make your life hell.
Yeah,
but directly you can add.
I think it's like adding a slider is automatic now in GeoGebra. So it's there's no pain at all in GeoGebra. But anyway, that is everybody's different preferences are there. So, but it's good to know that you can go from the statistical point of view to learn calculus also using Excel. So thank you, Chanchal Das. And
Thank you, sir.
if more people want later on, we may have a workshop on this later on. Many people want how to do it actually. So maybe a longer workshop, or you can announce a workshop and we can publicize it for you. So thank you.
Okay.
If anybody else has a question to ask? If nobody, let me thank Chanchal once again.
Okay, thank you, sir.
And
I'm very happy that you have provided me this option.
so thank you very much. And everybody, please fill up the form before leaving. The feedback form link is already circulated. So please fill up that feedback form and take care. Okay.
Lot of, sorry, why it is echoing, I don't know. Lot
Sir, please
of,
unmute your one device,
available
the
in
other
YouTube.
device.
You have two devices nearby.
But I am muted. Now, can you listen me?
Yeah, it's okay now. Please go ahead.
No, now.
You want to say something, Chanchal Das?
In YouTube, there are a lot of material about my YouTube also. If you give Chanchal Das all my old presentation with faculties and university teachers, everything available. So anybody interested, they can see that.
And I have also circulated in the chat box your email. So in case somebody wants to contact you, they will contact you for further information. So thank you once again. And everybody, please take care. Bye.
Thank you, sir. Thank